cointegration is a statistical property of a collection of time series variables. First, all of the series must be integrated of order 1. Next, if a linear combination of this collection is integrated of order 0, then the collection is said to be cointegrated. Formally, if R each integrated of order 1, and there exist coefficients A, B, C such that aX+bY+cZ is integrated of order 0, then X, Y, and Z are cointegrated. Cointegration has become an important property in contemporary time series analysis. Time series often have trends either deterministic or stochastic. In an influential paper, Nelson and Charles Plosser provided statistical evidence that many U.S. macroeconomic time series have stochastic trends. These are also called unit root processes, or processes integrated of order 1 I1. They also showed that unit root processes have non-standard statistical properties, so that conventional econometric theory methods do not apply to them. Introduction: If two or more series are individually integrated but some linear combination of them has a lower order of integration, then the series are said to be cointegrated. A common example is where the individual series are first-order integrated, but some vector of coefficients exists to form a stationary linear combination of them. For instance, a stock market index and the price of its associated futures contract move through time, each roughly following a random walk. Testing the hypothesis that there is a statistically significant connection between the futures price and the spot price could now be done by testing for the existence of a cointegrated combination of the two series. History Using the A2 statistic to assess the adequacy of regressions gives substantially misleading results for time series with trends. Before the 1980s, many economists used linear regressions on non-stationary time series data, which Nobel laureate Clive Granger and Paul Newbold showed to be a dangerous approach that could produce spurious correlation, since standard detrending techniques can result in data that are still non-stationary. His 1987 paper with Robert Engel formalized the cointegrating vector approach, and coined the term. For integrated I1 processes, Granger and Newbold showed that detrending does not work to eliminate the problem of spurious correlation, and that the superior alternative is to check for cointegration. Two series with I1 trends can be cointegrated only if there is a genuine relationship between the two. Thus the standard current methodology for time series regressions is to check all time series involved for integration. If there are I1 series on both sides of the regression relationship, then it's possible for regressions to give misleading results. The possible presence of cointegration must be taken into account when choosing a technique to test hypotheses concerning the relationship between two variables having unit roots. The usual procedure for testing hypotheses concerning the relationship between non-stationary variables was to run ordinary least squares regressions on data which had been differenced. This method is biased if the non-stationary variables are cointegrated. For example, regressing the consumption series for any country against the GNP for a randomly selected dissimilar country might give a high R-squared relationship. This is called spurious regression. To be more mathematically precise, two integrated I1 series which are statistically independent may nonetheless show a significant correlation. This phenomenon is called spurious correlation. Tests: The three main methods for testing for cointegration are Granger two-step method if E and are cointegrated, a linear combination of them must be stationary. In other words, where is stationary? If we knew, we could just test it for stationarity with something like a Dickey-Fuller test, Phillips-Perrin test and be done. But because we don't know, we must estimate this first, generally by using ordinary least squares, and then run our stationarity test on the estimated series, often denoted. A second regression is then run on the first differenced variables from the first regression, and the lagged residuals is included as a regressor. Johansen Test The Johansen test is a test for cointegration that allows for more than one cointegrating relationship, unlike the Granger method, but this test is subject to asymptotic properties, that is large samples. If the sample size is too small, then the results will not be reliable and one should use autoregressive distributed lags. Phillips Euler-Ulari's cointegration test equals Peter C. B. Phillips and Sam Ulari's show that residual-based unit root tests applied to the estimated cointegrating residuals do not have the usual Dickey-Fuller distributions under the null hypothesis of no cointegration. Because of the spurious regression phenomenon under the null hypothesis, the distribution of these tests have asymptotic distributions that depend on the number of deterministic trend terms and the number of variables with which cointegration is being tested. These distributions are known as Phillips-Euler-Ulari's distributions and critical values have been tabulated. In finite samples, a superior alternative to the use of these asymptotic critical value is to generate critical values from simulations. Multi-cointegration in practice, cointegration is often used for 2I, series, but it is more generally applicable and can be used for variables integrated of higher order. Multi-cointegration extends the cointegration technique beyond two variables, and occasionally to variables integrated at different orders. Variable shifts in long-time series tests for cointegration assume that the cointegrating vector is constant during the period of study. In reality, it is possible that the long-run relationship between the underlying variables change. The reason for this might be technological progress, economic crises, changes in the Fiopli Euro unregistered trademark S preferences and behavior accordingly, policy or regime alteration, and organizational or institutional developments. This is especially likely to be the case if the sample period is long. To take this issue into account, tests have been introduced for cointegration with one unknown structural break, and tests for cointegration with two unknown breaks are also available. See also, error correction model, Granger causality, stationary subspace analysis. References. Further reading, Enders, Walter. Cointegration and error correction models. Applied Econometrics Time Series. New York, Wiley pages 319-386. ISBN 0-471-23065-0. Hayashi, Fumio. Econometrics. Princeton University Press pages 623-669. ISBN 0-691-01018-8. Madala, G.S. Kim, In-Mu. Unit Roots, Cointegration, and Structural Change. Cambridge University Press pages 155-248. ISBN 0-521-58782-4. Murray, Michael P. A Drunk and Her Dog, An Illustration of Cointegration and Error Correction. The American Statistician 48, 37-39 doi, 10.1080/0031305.1994.10476017. An Intuitive Introduction to Cointegration.